So this is the first rule. So this is like the opposite of the power rule. Okay. Before, in differentiation, when you have, let's say you have x cubed, we know that the derivative of this is equal to 3x squared, right? Now, what if we're given 3x squared? How do we go back to x cubed, right? How do we go back there? So this is the first rule. Okay. So the antiderivative of a x raised to n is equal to, okay, so you see this pattern here. Okay. So we basically rewrite a of x, and then basically n uh, plus 1. Okay. N plus 1. Before, when we had x cubed, what do we do here when we get the derivative of x cubed? We usually subtract, right? We subtract the index, right? That's why it becomes, 3x squared, right? So this time, instead of subtracting 1, we add 1 now. And then, what happens here is your denominator, okay? So if n plus 1 here, your denominator is n plus 1 here. Okay, don't forget that. And then plus c. Don't forget your arbitrary constant c. Okay. Okay, so let's apply this. Okay. Now, in derivatives, we know that the derivative of any constant is equal to 0, right? Okay. Because, again, if you have your x and y, when you graph this, there's no gradient, right? Because it just creates a straight line. Okay. There's no gradient because it doesn't slant to the left or slant to the right. Okay, that's why the gradient is always 0. Okay. Now, how do we get the uh, antiderivative of such questions? Okay, so let's have letter A first. Okay, so the antiderivative of 5 is equal to 5x plus c. Okay, always remember that, class. So it's 5x plus c. So the derivative of any constant is just, okay, the constant itself plus, okay, and then you add x, okay, indicated by this, and then plus your arbitrary constant, or plus c. Okay, now how did this happen? So if we get the derivative of 5x, what is our answer? Our answer is 5, right? So it's the reverse of this. That's why we got 5x plus c here. Okay, so is that clear? Okay, so the antiderivative, or the integration of any constant, is equal to the constant, and then you multiply it by x plus c. Now, if this thing here becomes, let's say, the antiderivative of 5 with respect to dz, okay, that is equal to 5z plus c. Okay, again, this thing here is your variable here. Okay, so x. If it's x, it's x here. Okay. Now let's have another example. Let's have letter b. Okay. So for letter b, the antiderivative of pi is equal to, okay, obviously it's pi x plus c. Okay. So these are my two constant examples. Okay. So you just add x, and then that's it, and then plus c. Don't forget your plus c. Okay. So it's not that hard. Okay, now let's go to letter C. Okay, now what if we have x squared? So what is the antiderivative of x squared, right? So applying this rule here, this thing here, okay, so the antiderivative of x squared is equal to x cubed, because remember, this is n plus 1. That's why this is now 3. And then whatever your index here will be your denominator. Okay, so that's it. That's why it's x cubed over 3 plus c. So that's your answer for letter C. Okay, do you have any question, class? None? Okay, let's have letter D. Okay, now for letter D, what is the antiderivative of x raised to 5? that is equal to x raised to 6. Again, this is n plus 1. So basically, it becomes 5 plus 1. That's why this is 6. Now, if this is 6, your denominator is also 6. Okay, and then plus c. Okay, so that's your answer for letter D. Okay, let's have another one. Okay, now these examples here, class, are not in your book, so please uh, listen carefully. Okay, so let's have letter E. Okay, now what if we have uh, coefficient, okay, which is 8? What if we have 8x cubed? Before we just have x raised to 5 or x squared. So what now if we have coefficients here? So the antiderivative of 8x cubed is equal to 8 times, okay, the derivative of x cubed is this one, right? So this is, again, 3 plus 1. So this is also 3 plus 1. Okay, so these two are the same. And then you have your 8 here. So basically, you multiply 8 with the, okay, with the integration or antiderivative of x cubed, which is this. Okay, so basically, we can cancel out 8 and 4 because 8 and 4 are divisible by 4. Okay, so this is 1, this is 2. That's why your final answer is 2x raised to 4 plus c. So do you have any question with letter E? Sec 4? Okay, so do you have any question with our examples so far? Hmm? Sec 4, do you have any questions? Hmm? Okay, is everything clear? So I hope everything is clear, yeah? Okay, now let's go to letter F. Okay, so let's go to letter F. So what is the antiderivative of 5x raised to 6? So basically, 5 here is, okay, so we just rewrite 5. Okay, actually the longer explanation here is that, okay, this one, okay, let me write it here, is that you can put 5 outside the integration sign, and then you just integrate x raised to 6, okay, which is basically the same like here. Okay, so again, the antiderivative of 5x raised to 6 is equal to 5, and then x raised to 7 over 7. And again, 7 came from 6 plus 1. And then, of course, whatever your index here is the same as your denominator. So this is your answer. Since we cannot simplify 5 over 7. That's it. Okay, so that's letter F. Okay, do you have any question, class? Sec 4? No question? Okay. So everything is clear, okay? So the antiderivative or the integration of a constant, a variable with an index, okay, and a term, okay, wherein we have coefficient, variable n, and index. Okay, so that's how it's done. Okay, now what if, let's have a fraction, okay? So with this one, we just basically rewrite the question itself, okay? So instead of integrating 1 over x squared, so we just rewrote this one to become x raised to negative 2. Okay, so we integrate this. Okay, so the antiderivative of x raised to negative 2 is equal to, okay, this one. So it's a step-by-step process here. So x raised to negative 2, okay, plus 1, and then your denominator is also the same as this. Okay, so it's negative 2 plus 1 also, like this. And then plus c. So what's your answer now? So your answer is, okay, negative x raised to negative 1. Why is this negative x? look at your denominator. It gives you a negative 1, right? So that negative 1, basically, if you divide x by negative 1, you get negative x, right? And then this is negative 1, obviously from this one, okay? So negative 2 plus 1 is a negative 1 plus c. So finalizing your answer here, so it's negative 1 over x plus c. Okay, always express your indices in a positive index. Okay. So do you have any question with letter G? Anyone? No question? Okay, so everything is clear for letter G. Okay, so let's have another set of questions. Okay, so what if, let's have letter H here. Okay, so what if we have a surd or root of x? Okay, so the antiderivative of the root of x is equal to, okay, so what do we do first? We rewrite this. It becomes x raised to 1/2 with respect to x. So let's apply the rules that we have. So x raised to 1/2 plus 1, okay, and then so your denominator is also 1/2 plus 1, and then plus c. Don't forget the plus c. Okay. So basically 1/2 plus 1 gives you 3 over 2, right? And then over, your denominator is also 3 over 2. So your final answer here is 2x raised to 3 over 2 over 3. Now, if you're wondering how did 2/3 or 2/3 get here, okay? Now, let's go back here, okay? So before we got our final answer, remember that how do we divide fractions? Okay, we know that this is x raised to 3 over 2 times, how do we divide fractions? So we get the reciprocal of this, right? So we get 2 over 3. Okay, that's how we divide fractions. We multiply them and then we get the reciprocal of your denominator. Again, reciprocal means okay, you just switch their places. So this is how we get 2/3 x, okay? This is how we get this, our final answer, okay? So your denominator becomes your numerator and then vice versa, okay? So when you simplify this, you'll get this one, 2x raised to 3 over 2 over 3. Or if you want, you can write your final answer as this one. So 2/3 x raised to 3 over 2 plus c, okay? So it's the same answer, okay? So it's up to you. If you want to write it like this or like this, it's okay, okay? Still the same answer. So do you have any question with letter H? Okay, don't forget this because you will get a lot of questions like this, okay? X over a fraction, okay? So again, if it's over a fraction, you multiply and then get the reciprocal of your denominator, okay? So let's proceed to letter I, okay? Okay, should we proceed to letter I think. Okay, it's quite fast. Okay, so let's have some questions first. Okay, so because letter I onwards are now expressions. Okay, it's like the combination of everything that we have learned from letter A up to letter. So the derivative or the antiderivative of 2x cubed is equal to 2x raised to 4 over 4. Again, this is 4 because this is 3 plus 1. Okay, and then also this is 3 plus 1. So simplifying this, your answer should be x raised to 4 over 2 plus c. Okay, so that's your answer for letter A. And then for letter B, the antiderivative of -5 is just equal to -5x plus c. You just add x and then plus c. Okay. And then for letter E, okay, now I know some of you got stuck here on letter E. So you have, what is the antiderivative of 2 over root of x? Okay, so look here first. Okay, so you write 2 besides. Okay, so we get the, so we write root of x. Okay, so it becomes x raised to negative 1/2. Sorry, x raised to 1/2. So what do we do next here is to put it in the numerator. That's why it becomes x raised to negative 1/2. Okay, and then like the rules said, so we add the 1 here. Okay, so it becomes negative 1/2 plus 1. So that goes with your denominator. It's negative 1/2 plus 1. Okay, and then next is, let's evaluate this. So negative 1/2 plus 1 is 1/2, right? Okay, so it's like negative 1/2 plus 2 over 2, right? So basically this is equal to positive 1/2, right? And then obviously, I mean, basically your denominator will always, will always be the same with your index here. So if this is 1/2, your denominator is also 1/2. Now, how did this become a 4? So again, it should, okay. So we have 2 root of x, right? Or let's say 2x raised to 1/2. And then times, how do you multiply? I mean, how do you divide fractions again? So you multiply them by multiplying the numerator by the reciprocal of the denominator, which is 2 over 1. Okay, and then that's how you get your final answer. Okay, it's 4 root of x plus c. So that's your answer for letter E. Class, can you take a photo of your papers now? Finish or not? So I can see like on which part, especially on letter E and F. Okay. Can you guys take a photo? Finish or not? It's okay. I just want to see where you get stuck. Uh, okay. Esel? Okay. Tiffany? Okay. Justin? Rafa? Okay. So, yeah, Tiffany, these are correct. Okay. Yeah. A is correct. B is also correct. E is correct, of course. Then F is correct. Yeah. Hey, why didn't you send this on time? Okay. Okay, Tiffany, you're correct. How about Esel, Justin, and Rafa? Okay. Please take a photo of your work now. All right, now let's have letter F. Okay, Justin, Esel, and Rafa, I'm still waiting for your papers. Okay, so letter F. So we got 1 over 2x cubed, right? Okay. So what I did here is to just write 1/2, and then x cubed. Okay, it's moved to the numerator, so that's why it becomes x raised to negative 3. Okay, so you can set aside 1/2. Okay, and then let's integrate x raised to negative 3. Okay, so wait, let me put a bracket. Okay, so you have 1/2 there. Okay. All right, so getting the antiderivative of this, so negative 3 plus 1, right? So if this is your index, that is your denominator as well. So you have 1/2 or 1 times this. That's why it's x raised to negative 2. And then 2 times negative 2 is this one. That's why your final answer is 1 over, so this is 2 times negative 2 is negative 4. And then x here raised to negative 2 becomes x squared here in the denominator. And then plus c. So that is your answer for, okay, for letter F. Okay. Okay. So that's your answer for letter F. All right. So Esol, Justin, and Rafa, can you send your papers now? So I want to see them before we proceed to another set of examples.
I don't really get it.
Okay. So probably let's. Okay. So Justin, can you please let's just have another remedial. Okay. About this one. Okay. How about Esol and Rafa? Okay. Okay, now let's proceed to another set of examples. Okay, so let's have letter I. Okay. So just to recall, okay, so again, uh, so when you get the antiderivative of a constant, you just put in x plus c. Okay, so therefore your answer is 5x plus c. When you're solving for the antiderivative of x squared, again, this gives you x cubed over 3. Okay, Justin, Essel, and Rafa, this thing here becomes 3 because of the first rule that we have here. Okay, so the first rule indicates that because this is the reverse of differentiation, right? So in differentiation, we used to subtract 1 here, right? So your answer is 2x, sorry, 3x squared, right? But this is integration, so that's why this is the reverse of that. So instead of subtracting 1, so we do plus 1 in your in this index or indices. Okay, so that's why this becomes 3. And then also over 3. Okay, whatever your index here, it's also your denominator here. And then that's plus c. Okay, again, if you have x raised to 5, so the antiderivative of x raised to 5 is x raised to 6 over 6. Okay, so this is 5 plus 1, and then also this is 5 plus 1, and then plus c. Now, if you have a coefficient, which is 8, okay, you set aside 8, and then you get the antiderivative of x cubed. Okay, so the antiderivative of x cubed is x raised to 4 over 4. Okay, and this is 4 because it's 3 plus 1. It came from here. And again, whatever your index here is also your denominator. So simplifying this, your final answer is 2x raised to 4 plus c. Okay, so those are the things that we need to go to question letter I. Now, for question letter I, we now have an expression. It's like the combination of everything from letter A until letter H. So let's have letter I. Okay, so just 2 more examples, and then maybe 3 more examples, and that's it. Okay, so for letter I, so we have the antiderivative of 3x squared plus x plus 6. So basically, you need to get the integration of each of these terms, okay? So you get the antiderivative of 3x squared as well as x, and then as well as 6, right? Now, so the antiderivative of 3x squared is this, okay? So bring down 3. So the antiderivative of x squared is x cubed over 3, okay? Again, the antiderivative of x squared is x cubed over 3, okay? So let's leave it first. And then what is the antiderivative of x? Okay, so if it's x here, so 1 plus 1, right? So the antiderivative of x is x squared over 2, okay? Because this is 1 plus 1, that's why you got 2 here. And then again, whatever your index here will also be your denominator. So that's why the antiderivative of x is x squared over 2. And then basically the antiderivative of 6 is 6x, okay? 6x from our previous examples. And then plus c, okay? So we just add plus c once in an expression. So simplifying everything here, so we'll get x cubed because you can cancel out 3 and 3 here. And then plus, so as is, and then 6x plus c. So this is your final answer for letter I. So do you have any question, class? For example, letter I. Boys, Justin, Hazel, Rafa. Do you have any question?
Mm,
No.
I
Okay,
get it.
so this one is like the combination of everything from letter A to letter H. So I will upload this video later in our class, so you can rewatch this. Okay, now this is my last example for today. So let's finish at letter J. Okay, so letter J, so we get the antiderivative of 9x squared plus 2x. Okay, so we get the derivative of each term. So the derivative, the antiderivative of 9x squared is this. Okay, so bring down 9. Okay, boys, bring down 9. And then we get the antiderivative of x squared. So it is this again, x cubed over 3. So again, it's cubed because it came from 2 plus 1. So again, whatever your index is your denominator for this one. Okay. So this is the antiderivative of 9x squared. How about for 2x? So for 2x, so just bring down 2. Okay, just rewrite 2. And then what is the antiderivative of x? So it's x squared over 2. Okay. Okay, now if you're confused with this kind of working, you can always write this as, okay, let me write an alternate working. Okay. So this one is, you set aside 9 and then x, sorry, so x cubed over 3. Okay, so that's one way of writing your workings. And then plus, okay, so you have 2 here, right? So you just put 2 outside and then you get a bracket, and then the antiderivative of x is x squared over 2. And then that's it. So this is an alternate of this. Okay, but basically they're the same. Okay, they're the same. So if you're confused with this, you can write this as this one. Okay, so therefore your final answer here is this one. Okay, so this is 3x cubed because 9 and 3 can be divided, so that's why you got 3 here, just like here. Okay, and then this is x squared because 2 divided by 2 is 1, so just like this. And then plus c. Okay,